So this housing here is a component that goes into an autonomous agriculture application. This is part of a family of parts and part of a family of integrated assemblies that we build for the customer. And the customer came to us kind of very early on in the development cycle of these assemblies, an assembly that they had built in-house. And ultimately, the customer did not want to be in the business of integrating all of their sub-assemblies. So they had, at a very early stage, kind of crudely mocked up what they were looking for and, came to us essentially with that mock-up and said, here's the functionality we need. Here are some items that we'd like to clean up. And, here are some potential changes that we'd like to roll in the near to midterm. And so we started running this part, and there are probably about a dozen other parts that go into the assembly that actually ships to the customer. We started running these parts at a very low volume initially for, really first article inspection purposes for the customer. And then as the customer tested them, there were, a few design iterations, and, then we started shipping in more production quantities as the design matured. The main issues that we encountered kind of in those early stages were that the customer had a functional prototype, but it was not manufacturable. It was not repeatable. It had been hand assembled by the engineer who was responsible for this functionality internal to the customer. And, they had done a great job and it worked great, but that was not a process that would be repeatable at a reasonable cost in any sort of volume. And so a lot of the initial effort really was focused on the mechanical side, just mechanical repeatability in the assembly. And, so whether it's adding locating datum features or pins or, features that would just drive repeatability in the assembly in order to control cost while maintaining the desired level of functionality. So this assembly does see a rather harsh environment. It is outdoors. It's, as I mentioned, an autonomous agriculture application. So it's out in farm fields. It sees weather. Weight is a consideration just because it is moving and there are multiples of these assemblies on vehicle. Cost of the material obviously was a consideration again because there are multiples. And, ultimately a part like this housing is necessary to the functionality, but it needs to be as inexpensive as it can be. It's really not the primary portion of the assembly. There are sensors and electronics and things that are really doing the hard work. And so this particular part is unfinished. The end parts in the field are hard anodized for corrosion protection and for general toughness. So the bulk of the external machine parts in the assembly are 6061 aluminum, and then they're hard anodized. And that selection of material was a pretty good compromise, I guess, in terms of all of the functional requirements, and then cost and machinability. The process initially, as I mentioned, was really focused on the driving repeatability at the assembly level. And so we looked at each of the mechanical components in the assembly, on the order of a dozen pieces, and really kind of worked back to sort of first principles in terms of how the assembly was going to be built, because that really that's not how it was designed originally. There's a design process where, maybe perhaps the customer had an existing piece of hardware and, it sort of evolved into this new thing. So we were able to basically divorce ourselves from all of the history of the assembly, and so really kind of work back to first principles from the functionality of the assembly to the number of parts that were there, and then how one would want to go about assembling it. Also considering field serviceability in terms of, if there was a component failure, say on the electronic side or sensor side where something needed to be replaced, but also from a future-proofing standpoint, that there are relatively short development cycles on a lot of the electronic components, again, kind of the heart of the assembly, and that we really wanted to try to make the mechanical portion outlive all of the sensors and things that would be inside of it. So really based on manufacturability, ease of assembly, and then ease of field service. So we handle production through a certain volume, probably in hundreds or low thousands of assemblies. Eventually, the higher volume production was transitioned offshore, but at that point, we kind of fell into a complete next generation design cycle with the customer to start over, essentially, where essentially there had been enough changes to their process and their hardware that there really was not room for further evolution in the hardware, and they were really starting over. And so we kind of fell into that next development cycle, and we're now sort of really involved in the pilot production of the second generation. So this particular part is not terribly complex on its own. It is, for our experience and our tool set, a pretty good fit in being a relatively small 5-axis aluminum part, fairly straightforward to automation. As I mentioned, there is a family of parts. There are variants on the assembly, so there are rights and lefts, and there are some other subtleties at the assembly level that require multiple different iterations on the assembly. The bulk of these parts do not require incredibly tight tolerances, but there are a handful of very tight tolerance features that directly feed into the end functionality of the assembly. So there was a lot of effort kind of in the manufacturability stage as we were working through fixture design in really understanding sequence of operations and how to approach making the parts to make sure that we're really focused on the few key critical features. I believe that the big advantage, I guess, with our involvement in the project, there are a few different parts of that. One is the ability to very quickly move from that DFM phase and then very quickly work through multiple design iterations at the front end of the project, and then to have one entity, in this case being us, responsible for the ultimate functionality of the assembly. And it removes complexity on the customer side in terms of having to manage the BOM, relatively small, as it is, removed that level of complexity on the customer side, and also removed, the requirement for the customer to have assembly technicians and to have diagnostic testing capabilities for the pilot production of these complete assemblies, rather than customer sourcing parts individually, bringing everything in-house, and then being responsible for integration on their own. So the end result was ultimately better cost control on the assembly, better cycle times on design iterations, and even below the level of a hardware design iteration, if the customer wanted to make a change to an acceptable test level, at a diagnostic test, somewhere within the assembly as it's being built up, it allowed for a lot of flexibility for the customer to, even while they were running pilot production, say with a process of record, that they were able to have us support R&D activities by, making specialized assemblies on the same assembly line, but say to a different set of diagnostic standards for next generation testing or whatever the requirements might have been.